The materials today is with continuing about the second topics of data analytics. In the last meetings, if you remember what we do in the last meetings, we do with the data descriptions. We exploring how to describe the data using the graphical, the chart, and also with the statistical descriptive for the advanced level. And last weeks we are trained about how to combine two category of data using correlations and comparing with the another score or another value from the variables. And today we are in the second topics. We talk about the inferential statistical. Okay, what is inference? Is containing two options. We are talk about the sampling and the sampling distributions, and also about the confidence interval. We starting about the sampling. A sample, or we talk about we learn about the sampling. A sample is kind of a typical statistic that we need to discover their characteristic of variables, even they are expressed in number or expressed in a categorical, like perceptions such as agree, disagree, you will continue or discontinue. That's the kind of uh, how to express the data using the expressions or using the number. Let's say that's between 0 to 100 number. And then it's generally some of the data is difficult or even it's impossible to be interpreted with the any kind of the characteristics. It could be we have the differentials informations among the respondents or also with the value of data. Let's say that what do you think if I say that you have a score of 7? What do you thinking, Clinis? If I say that you have a score of 7, what is your mind? You didn't think anything? The 7 is completely good. Maybe you can say it's good. What's about your opinion, Yasin? If I say that you have a 7, you scored 7, what do you think? Maybe we are in a test and you got a 7. A 7 is a very relative. Sometimes we can say that it's a difficult or even impossible to interpret. A 7, it's we can say that a 7 is quite high because the highest score is 8. That's maybe a very great score. But let me thinking that if your highest score is 100, a 7 is very low. So that time is very difficult to interpret. If we doesn't know about the characteristic of your score, the characteristic of your variables. So we need to identify what is the characteristic of our data. This is the starting point that we need to stand off about discussing about the samples. The sample is defined with the two category. In the big view or in the highest parts, we say that there is a populations. We can say that you are in the part of the populations people in the Philippines, and you are only the samples from the region Eastern Samar. That's the differences between the populations and a sampling, because the population is taken a whole of positions. It's different with the sampling. And the sampling positions or in the sampling data is depend on how we take the data or how we gathers the data. You can take with very advanced statisticals like the probability, you only take a 10% from your samples. Sorry, foreign populations. Let's say we have thousands of populations, so we only getting hundreds of samples. That's the kind of probability. Only 10%, or which is there is the probability in the main part of your samples. In another conditions, we also take for judgmental sampling. It's based on your individuals, based on your characteristics, or based on your subjectivity. Let's say that we only take the sample from Eastern Samar province. So there is a judgmental samples, or only we take for the biggest island in Philippines, like the I don't know, it might be Mindanao or Luzon's. It's depend on how we take the judgment or how we takes the criteria. That's the differences between a populations and a samples. So sometimes if we find about how to selecting about a sample, we face off about the bargaining informations. We call it a trade-off between the cost and the accuracy. When you gather a samples, it should be costly. Let's say that you want to take perceptions from any peoples or students. You need to uh, separate, or you need to spread with your physical questionnaires maybe, or sometimes you will share about the Google links, maybe for Google Docs links, or maybe with the indie survey monkey like that, or you can share with another incentive. If you can fill up from the questions number 1 to the last questions, you will get some amount to pay about the time that you have shared to fill out your questionnaire. That is the trade-off between the cost and the accuracy. The another point is about the accuracy. Sometimes we found that people who fill up the questionnaires or the respondents are not in positions, or we are not in the positions or the good positions. Let's say that we need our selective respondents, it should be in the CEO positions. But as we know, CEO is very busy. They have lots of agenda and they have lots of meetings. So they can't be to fill out about your questionnaires. Even you are in a great positions in your university. Maybe they will took the questionnaires and take the assistants to fill up with your questionnaire. That is the problem about the accuracy. So how to fill up about the respondents, or how to gather the data is uh, the kind of a trading off between the cost and the accuracy. And for our category, like students, like university member, sometimes we need lots of the respondents, a lot of this is the mass of data. So if you have any kinds or very much of data, you need to getting with a cheaper cost. Sometimes you need with the easier way to gather your data, and but you cannot bargaining with your accuracy of informations. So this is the three category how you select about your samples. Your data should be in a cheaper cost to gather, easier way to gather, and more accurate. The next, we talk about the kind of sampling. The first and the very simple in a sampling methods, we call a simple random sampling. As the name is very simple. It's also, it's not in the name. It's we taken by a random positions. So doesn't think anything. You only pick, choose what you want. That's a random positions. So the simple random positions is how to gather your data with every possible sample size. in the same probability, doesn't think for any criteria. So it's very easy, it's very simple. That's why we call it the simple random positions. But remember, you have the number of data or the populations. You should know about the populations. In statisticals terminology, we call about a finite populations, or in the simple way, we call countables populations. So you need to know how many, how much your populations. This is the important things that you will learn about the simple random sample. The simple random sample is require about a large area, or maybe with the large number of sample. So even they are very simple, they are very easy, but you need to have lots of populations. Let's say that yeah, we just say in an exam exercise, considering that we have 40 families. This 40 families is a data in our populations. So to getting a samples, you only take 25%. So we take a 10 random sample from 40. 10 out of 40, it means that we need to getting 25% of data from the populations. So in the Excels, you can use with the ran functions or ran between functions. I will show but how to do it in the Excels after the introductions. Okay. The next positions or the next type to gather a sample or sampling is about the systematic sampling. What kind of systematic samplings? You need to make some order about it's a very systemic. You need to with the first part and then going to the second parts. So we need to divide about your population size. Let's say we have 1,000 populations. We need to divide in a two category. The first 500s and the second 500s. So that is the blocks or the systematic samples. You need to gather from the first block, the first peoples, 500 peoples, and after that, you go to the second block. So you go to the 500th another people to take a samples. That's we call systematic samples because we have a criteria. A systematic means that you need to set about your criteria. Or sometimes we create about the blocks to divide the number of samples. Yes. Okay, the systematic samples doesn't require the equal number. You can say that the first block is only 500 people. The second block is only 100 people. The next block is only 300 people. It's depend on your subjectivity. Even we call it about the systematic samples. So it doesn't need about the equals number of proportions. The kind of systematic sample is about stratified sampling. We need to create about the stratum, the grade. Let's say that you need to take a sample from a student from grade 1. After then, you go to the grade 2. Take another samples and moving to the grade 3 and then later. That's kind of a stratified sampling. You need to separate your samples into differential grade or differential stratum. In the stratified samples, you need to thinking about the proportions. The proportion should be equal. So this is like a systematic samples, but the differences is about the sample size. It should be in proportions. So 100 people in the first stratified. In the second grade, we need 100%. And the next grade, we need 100%. So it should be in equals number. Is it clear for you? Yeah. The differences between a systematic and stratified sample. Let's say that we have the stratified sample from 50,000 people. We need to stratify by the age. The age from 18 to 30, 31 to 62, 63 to 80. This divided by the difference or the subjectivity by the research. So in each samples, it's containing about 200 peoples. So let's say that this one is in unequals number. In every stratum is containing 200 peoples. The next type of sampling methods is called the cluster sampling. It's like your territory or in your geography. You need to separate your populations into different clusters. Maybe in a country, we need to separate in a city or maybe in the municipals or the province. That's kind of the cluster. So you need to pick up your data or the samples based on your cluster separations. It's maybe for the cost of take these actions or the advantages is having the low cost than another's methods. So this is a cluster sampling. How about if you want to take another data or gather data with more than one sampling methods? It is possible because you can use the complex stage of gathering of data with the difference of sampling methods. We call it the multi-stage sampling scheme. What is the mean of the multi-stage? Multi-stage. You need to minimum two kind or two type of cluster samplings or maybe with the sampling methods in a different positions. The first part maybe let's say that we need a simple random samplings. We take 100 people from all of the populations. That's the first stage. The second stage, you need to gather data using the cluster sampling. Even you only have two kind of sampling methods, we call it multi-stage sampling schemes because you have more than one sampling strategies. Okay. With all of the sampling methods, any questions before we continue the materials from the students, Plinis, Fannis, Yasin, Zitabel, or Oliver maybe? Any questions?
None so far, sir.
None, sir.
Okay, none so far. Thank you for responding, Plinis and Fannis. Okay, next to the second topics is not only in the sampling innovations. We call it the estimations. After we gather the data from the populations, we go to the sampling. And then after that, we cannot calculate how we make some error in our samples. That's thinking that even we have reduce or resize our samples, it's also containing with the errors positions. We call it the estimations. It's a same informations like you have a standard deviations in the first meeting about the data analytics. The estimations is talk about how far or how wide of how far the range of your error using your mean or median estimations or in standard deviations of your samples. The source of estimation error is comes from the samples or out of them. The sample error, let's say that we have the uncontrollable informations that should be tackles, but we cannot do anything. Let's say that we need a response from the CEO, but if you're thinking about the busiest activity, the lots of agenda, we can do, or we have any errors if your respondents or your instruments is filled out by non-CEO. The next error is comes from the non-sampling activity. It's let's say that it's uncontrollable error, like the bias errors from the respondents. If you have the ambiguity in your sentences, or maybe with your any kind of interpretation of your data, or some of your respondent are not expressed in a truthfully conditions, or maybe you have a sensitive questions, we have or we will face about this kind of error. The another error is come from the measurements. It's from the rater, or from the rating or scores, or the value that should be you put on your data. Let's say that we have the equals a score from the Likert scale, maybe for the 1 to 5. It doesn't mean that you have an equals range for every perceptions. So we need to take some options or take some justifications to ensure that your data is free from error or free from measurement error. The next is about the voluntary response bias. If you have respondents, or if you have some from the students that should be fill out your questionnaires, or maybe with your data, or you take some actions with your respondents involuntary, please considering about the voluntary response bias, because maybe there are any potential respondent that should be filled up with non-informations, or without the general informations that should be having or knowledgeable in your respondent. Okay, it should be enormous in your data. So there is about we talk about the sampling category or the sampling actions. We known about the kind of error or the estimation error of your samples. So please be careful and considers any kind situations or any conditions that will make your value or your score or your data gathers will be out of your estimations. And then please ensure about the distribution of samples. Even I don't know there is lots of samples, or maybe the higher populations, you need to considering about the sample size, the size of your objects. It should be taking some informations about the possibility if you want to gather some data. The next, we will talk about the confidence intervals. Before I learn or take on informations about the confidence intervals, have you heard before these sessions about the confidence interval? Have you heard about this name, the confidence interval?
Yes, sir.
Okay. Uh,
Yes, sir.
okay. What is the next? Not yet from Oliver. Okay. What is the kind of considering about the confidence interval? The confidence interval is the gradations, is the percentage, or is the degree of your truthfulness into your data. The confidence interval, it means or representing that how you faithful, or how you believe that your data is completely true. The data is completely free from bias, free from the measurement error. That's the name of the confidence intervals. Uh, let's continue about the confidence intervals. The confidence interval, okay. The confidence intervals is the kind of statistical inferences that should be underlying, that should be taken into the probability models, because you cannot predict, you cannot measure all of your data, and you cannot generate or make your decisions with general assumptions or with lots of informations. So we will use about the confidence intervals. The confidence interval is containing how we represent, how we believe, how we ensure the data. We say in the proportions or in the percentage. This is the kind between a 0 and 1. It means between for 0% to 100%. Let's say that's yeah, and sorry. Let me give some example. Yeah, this one, it is examples. Okay. We have sometimes we have these three parts of informations about the confidence intervals or confidence level. This is your confidence level about your data. Let's say that we have 90%, 95%, and 99%. Let's start about the 90%. The 90%, it means that you prefers or you trust your data only in 90%. So you believe your data is containing 10% of error. Okay. If you say that you have the confidence level 90%, it means that you believe 90% from your data. In the same time, you also believe that your data is containing 10% from the error. So it's perspective to Sam's perspective comes to the 95%. You believe in 90% the truthfulness of your data. And you also believe that your data containing 5% of measurements error. A similar way to say that 99%. You you think that your data is only contained with a 1% of error. So after these positions, we can compare. If you think that you have a good data, you have a good respondents, you think that your respondents or your samples will fill up your data, will express the very truthful of your data, you can take highest positions, let's say 99% or maybe 99.99%. We cannot say in 100%, because as a statisticians, we know that there is any error in your data, even they are in 0.00001%. Your data is still containing with an error. Is it clear for you? Yeah. We cannot say that you believe 100% your data. You just put there's a one error in your data. You can say in 10%, 5%, 1%, or maybe uh in the fewer number. We are in the social science, an accounting, a businessman, and management studies. We are in social science. So our decisions is affected to the human or organizations. So we can use about the medium interventions like the 95%. So we still believe that our data is containing 5% of error because we are in the socials. Um, our decisions sometimes affect the organizations, but in a long way, it should be maybe the organization should be in bankruptcy or having the distress or maybe in dangers, but not in an instance conditions. But remember, this confidence level is depend on the science, depend on your confidence, Lizzie. Let's say that if I change my positions, not in a science methods or in the science, in the social science, let's say that I am a pharmacist or I am a doctor. So I cannot say that I believe in 90% or 95%. Maybe I should take about in 99.99%. Let's say that I'm a pharmacy. In the pharmacians, I create some medicines. So I need to very confidence with my data. Let's say that I will test for the medicines for every people's and I check it's very going better or going to the bad or maybe it's very danger for the peoples or maybe from the uh, animal samples like that. So I need to believe very, very truthful about data. It's 99.99%. Because if we have an error, if we make some mistake with the medicines, um, the effect is very dangerous. It's a death for the people. So we cannot uh, make it up again. It's different like the organizations. If your organization is going to bankruptcy, you can build up again. You can create another business, but it's difference between the people's or the human life. If you make some mistake in a medicines or maybe in a in doctoral studies, in like the medicine studies or maybe in the vector microbiology like that or the physics, your effect will be on a death and we cannot waking up the peoples. So we need the highest confidence level. So yeah, I think there is I need to share about you about how to select about the confidence levels. Even we are in social science, yeah, you can say that we have the 90 or 95, but in the physical science or maybe in the medicines of science, we need the high fully uh, trust with our data. So this is the differences between the different degree in confidence levels. Okay. Any questions from you? Wait. I need to clear the drawings. Okay. Yeah. Let's see about the examples of our data. Yeah. Sorry. I missed this one. The chi-square informations. The chi-square is using for the variability when you cannot count your populations. So as I say before, if you are using the simple random sampling, it's very simple, but you need to know the count, the number of your populations. We call it a finite population in a statistic. But in some cases, we cannot count the samples or the populations. We say that this is an infinite populations. For examples, for the real examples, can you count how many stars in your sky in the night? It could be a hundreds, it could be in thousands. So in statistical, we only say this is infinite. It's uncountables. So we can use about another kind of distributions named a chi-square, not a chi-square, a chi-square. So this is beyond the normal distribution because we cannot count our populations. So please remember that our stand position is can you count your population or not? If you can count your populations, you can use a simple random sampling, stratified sampling, systematic sampling, or cluster sampling. But if you cannot count your populations, you just do with the chi-square distributions. Okay, let's say about the examples. The examples is depend on the sample size. Okay. You have three kind of data. Data number one is about the questionnaires. Data number two is about the supermarkets, and number three is about the salaries. Yeah, you have a data salaries like here. Yeah, I think it's a salary of 2015. Okay, let's start about the data number ones, the questionnaires for our exercise. Okay, I hope my Excel's point or this number is very clear for you, because sometimes the difference in a Zoom's camera is like a difference. So we have the data from the persons, the age, the gender, the children, the salary, and the opinions. So the first parts we need to create about the samples. Let's say we have the 30% in here. The 30% is the populations. So we can say that the populations is 30. Okay. We need a sample. So if I say we need a samples, do you know how much the samples that we can take from this data? Let's say a number from Venice, Citabel. Can we say I take the samples is 32? It's possible?
Yes, sir.
Is it possible or not?
Yes, sir.
Yes.
No.
Okay. No, good question. Thank you for responding, Oliver. Yeah, if you have a populations, we need to take a sample is a part of the populations. So the number of sample, it should be
Like
low of your populations. Yeah. Let's say that I have take a 10 samples. So it's very proper because the most of data is only 30. If I have a 32, it's two data is missing out from the samples. Okay. So we need, like say that we need to take a samples of 10. The sample of 10 in a simple random sampling. We start about the simple random samplings. Yeah, that's a funny. Yeah, you can take some errors from data. I'm agree with that, Sidabel. Okay. Let's say that we need to take a 10 of data. So in a simple random sampling, you only choose or pick a 10 peoples. You can pick with the first 10 persons or the last 10 persons, or maybe you can make what any kind with you want. You want to number one, number five, number six, number that, and then you can do with the random numbers with kind that you can choose about this one. So in these positions, I will overview about the kind of statistical methods that you can do in these samples. Let's say that we are using the rand number, the rand between. We have 10, sorry, we have 30, we have 30 data. Sorry. Hmm. Okay. We have the random between. Yeah, we need to include but the bottom numbers or to the top numbers. We only have 30 populations. So we need to pick with the bottom number is person number 1 and the top number is person number 30. So we got samples number 19. This one is our first sample for the simple random sampling. Okay. The next is, let's say we have the number 21. We need to take 10%. So this is the numbers that should be taken from your populations. So just do with the formula ran between. This is the first exercise for today. How to create about the simple random sampling with a statistical process. Okay. You can see with your functions. How about if their populations is more than 30? Let's say that you have the 50 populations. You just change with your top number 50. So it will be changed. It's difference. Okay. That's the first one. The second, we need to analyze the data with the data analysis. Okay. We can comparing with your possibility of samples. We have t-test and z-test. Z-test is for the lots of data and t-test is for the minimum data. So if you have the paired sample, you can do with these ones. So it means that your sample should be in equal number. But if you doesn't have the equal number, you can choose with the two samples for assuming equal variance or unequal variance. This one, if you think that your data having the similar mean and medians, but you doesn't sense that your data is equals in the mean and the medians, you can use with the unequal variance. So for the starting points, we need to calculate. Let's say that uh, we need to in positioning, sorry, we need to do with this one. With the filter of analysis. Okay. I have filtered these ones. We need to separate the samples with a difference. Oh, no, no, no. Let me change with another example from this one. This is very rich of data. The second one is about the supermarket, the data number 2. So let's say that we have the product for the family, food, drink, and non-consumable. So we need to create the 3 kinds of observations from food, drink, and a consumable. Okay. Let's say we need to compare the revenue, comparing the revenue from the family that's consuming food. We get this one. We have the data from food, food only. Okay. So you can see that it's very nice, a very long of informations. You can take it all. Okay. It's like the lookup salary like here once. You can get the data from catcher, center fielder, design hitter, first baseman. It's different numbers. It's not equal. So when you do this one with this uh, t-test or the data analysis, you can use with the 2 samples for equal variance or unequal variance. If you think that your data have the similar mean or medians, you can use with these ones. You cannot do with these ones because the samples is not in pair. The number is very different. let's say that we think that we have the equal variance. We can comparing from the catchers. This one is catcher. So, and the second one is center fielder. Catcher and, sorry, center fielder. The main difference, we think that there is no discrepancy. There is no differences. So we need to say that the difference is 0. It means that there is no differences. So let's say that we have a labels into the top of the units, and this one is an alpha. What is the mean of alpha? The alpha is correlate with the confidence of interval. If I say we have alpha 0.05, or it means 5% of alpha, alpha is represents the error. So in this part, we have the confidence levels in 95%. Okay, I repeat. If you say that you have alpha 0.05 or 5%, it represents a 5% of error. So in this case, we have the confidence level of 95%. If I change that, I think my data is having 10% of error. You can change this one. So this is based on 90% of confidence level. So we can compare the results. The first part is from the alpha 10% or the confidence level 90%. Okay. This one's the another one is we change to 0.5, 5%. We take the access here. Okay. Let's see. Okay, let's see the differences. This one is based on 90% of confidence interval. I say CI, okay? This one is 95% of confidence interval. So let's compare these informations. This one is from 90%. The second one is for 95% of confidence level. So we need to take an error 5% and 10%. So in the 10% of error, we found about the similar mean or the similar average of the data from the catcher and center fielder. You can compare these ones. In the 90% and 95%, they are extremely similar, right? Because we're doing the equals data. We do with the same data. The observation is 70 peoples in the catcher and 59 for center fielder. Okay. The difference is only in this one, in the critical t value in the statistical. Okay. In the 5% of error, the critical value is become high because the confidence level or confidence interval is increasing to 95%. So the critical value of this score is getting high to 1.65. But it's very different with the 90% of confidence levels. It's just 1.2 in a score. So it's very low than the 95%. So the confidence levels compared to the another confidence levels is getting with another's positions from the critical value of t-score, of the t-test score. When you have or you set about your highest confidence level, you will get the highest t-score. But if you set with the low of confidence interval, but you think that you have lots of error, your confidence levels and your t-score is getting down. Maybe decrease to or closely to number one, because one is the stand-up point for the mean or the average of the data. So this is the differences. But the another of the statistical calculations, like the mean, a variance, and hypothesis mean difference is completely same. Okay. From these examples, any questions from you?
None, sir.
Okay. Thank you for responding. Yeah. After this ones, you need to complete about the individual exercise using the data in data number ones, the questionnaires. You can create with the cluster data, maybe from the number of childrens. You can separate in the children zero or doesn't have a children, one children, two children, or three childrens. Or you can create with the another separations from the opinion, 1 to 5. One is repressing about the strongly disagree, two is disagree, up to the number 5 is about the strongly agree. Or the another ones you can choose with the separation using the gender, 1 for male, 0 for female. It's coded by the data in Microsoft Excels. In the second data from the supermarkets, you can learn about the coding of the food product family like these ones by the food, drink, or non-consumables, or you can separate using the homeowner, your customer having the homeowner or not, or you can choose with the marital status, a single and married, and also with the gender, male or female. So you can do with lots of informations in this one, this data. And from the salaries, you can do with the any kind of position of a basements and positions of in a sport uh, activity, like the hitter, baseman, pitcher, and the shortstop, and also with the fielder. So you can do with this one of analysis using the informations that you have learned and shared for today, and you can upload your exercise here in your Ukrida virtual class or UVC, and I give you 24 hours to complete with your exercise, your individual exercise, and upload to your UVC. To remember your previous meetings, I have take the link for class recording for the previous sessions in a 6 My, and you can access from here. And also I remind you, if you miss about the previous exercise, you also upload your exercise in here. But I think all of you is completely finished with your previous exercise. I think that's all for tonight, and you can continue with your individual exercise with your analysis using the confidence intervals, how to creating or separate with the samples. Please remember that you only use with the kind of sampling methods that we have learned today if you know your populations. The countable populations, or in statistical we call the finite populations, you can use with the simple random sampling, or you can take it with a stratified sampling, or maybe cluster sampling, or another of uh, systematic samplings. But it doesn't know about the number of your populations. It's still uncountable or infinite. You only use with the chi-square distributions. Okay, please do individually, and we can check it for the completement in the next meetings, and we can continuing about how to predicts with number or predicts with an observations. And in the next meetings, we combining about the calculations for correlation, the mean, medium into the prediction model using the simple regression model. Thank you very much for coming in time for our sessions today, and we will meet again in the next meeting in the same of schedules in the next Monday at 5 p.m. in my country, maybe 6 p.m. in your country, and we will do with another exercising. And please check with your Ukrida virtual class. Maybe I upload with the materials or with a link for your assignment. Thank you very much for coming, and see you next week.